Hey folks, it's B Mays back again with another awesome Armattan build. Today we're going to be building the TriCopter 355. So let me get everything laid out and I'll show you all the bits and pieces before we get started. When you receive your DIY kit from Chris at Armattan Quads, he provides everything that you need to complete your build, even solder. The only thing that you will need in addition to this is a soldering iron. I'm just going to go over everything that you get with the kit. He's now including the newer, better gym fan props with his DIY and RXR kits. This is the tail motor assembly. Our center plates come pre-assembled. We have our top plate, 3 motors, and I've been using these now for my last 3 builds, and these are excellent motors. These are just what you would call the Armattan house motors, but these are excellent motors. We have the, we've got the 2 front arms and the rear arm. This is the 355 model, so these are a little bit longer. We have all of our connections that we're going to need to mount our flight control board, power distribution, legs, and whatnot. This is the tail servo, the mullet flight control board, power distribution board, battery strap, battery wire, XT60 connector. We have everything that we need to build the kit. Let's take our time and build us a TriCopter. The first step that we're going to want to do in building the TriCopter is complete the frame. We've got the 2 front arms, our rear arm, 6 12mm bolts, nylock nuts, and the center plates as they come from Chris at Armattan are going to come pre-assembled. You'll see we have our standoffs here for our flight control, our power distribution board, and our flight control board. So all we really need to do is install the arms into the center plates. And we're going to do that by using the, like I said, the 12mm bolts pointing downward. And then put our nylock nut on the back. There we go. Now we're just going to tighten these up. These are 5.5mm or 7/32 in SAE. Tighten these up and I'll be right back. Next, we're going to install our 2 front motors. This motor will turn in the clockwise direction. This motor will turn in the counterclockwise direction. And the tail motor will turn in the clockwise direction. Right now, we're only worried about the 2 front motors. The screws that we'll be using for the motors are the 7mm bolts. We're going to position our motor so that our wires are facing the inside of the arm like this. And like we did on the CF258 build, we're going to put just a little dab of Loctite on each one of the screws. We don't need this. Now, since this happened to me, I'm going to show you what I'm going to do to fix it, what you can do to fix it. My motor holes aren't lining up the way I want them to. We've got 2 that are spaced further out than the middle ones, and if I line everything up, my wire is coming off the edge of the arm like this, and I want it to come straight down the middle. And where it lines up correctly is actually on the other side of the arm. So I'm going to take this arm off, flip it around, and I'll be right back. Now that I've flipped this arm around, my wires should come out here pointing straight down the arm the way I need them to. Next, we can start installing our ESCs. Now, I was going to only cut off the front portion of the clear heat shrink so that I could desolder these wires, but my heat shrink is overlapping where I need to desolder those wires, so I'm going to end up having to take the whole clear heat shrink off so that we can desolder these wires, because we're going to solder these wires from the motor straight to the ESCs. So now that I have the clear heat shrink tubing cut, I can remove it from the ESC. This is, by the way, why Chris provides us with new heat shrink tubing, so that we can actually remove these wires and solder directly to the motor wires. I'm going to need to be careful though, because we don't want to damage this silicone layer on the heat shrink, but we're going to need to remove that so that I can get to these wires to get those off of there. I have removed the heat shrink from the ESCs and desoldered the wires. I actually desoldered all of the solder that was on there from the factory because I just didn't like how much heat that it took to desolder those wires. So I'm actually going to be using the solder that Chris has provided, because I believe that that's going to be a little higher quality solder. But all we need to do now is we're going to snip off these bullet connectors and we're going to solder directly to the wires coming from the motor. I'm going to turn this around here. The motor rotation is going to be clockwise, counterclockwise, and then our rear motor is going to be turning in the clockwise direction. What's neat about this is if we look at how our wires are coming out here, these are coming out perfectly straight. They're not crossed or overlapped. In order for us to know that our motor is going to be turning in the correct direction, which is going to be the clockwise direction, we're just going to want to take two of the wires, and it doesn't matter which two, but we're just going to crisscross. So we can take the outside wire like you would if you were going to braid. Just take the outside wire, put it in the middle so that we have the crisscross, and then we're going to solder it to our ESCs directly like that. And then we automatically know that that motor is going to be turning in a clockwise direction. So I'm going to do that, and I'll be right back. I have the top left motor all soldered up to the ESC. You can see here that I have the outside wires crisscrossed, which is going to make this motor turn in the clockwise direction. All we need to do at this point is slide the heat shrink that Chris has provided down over the ESC, making sure that we're covering all of our connections, zip tie it to the arm, and we're ready to move on to the next one. This motor will be turning in the counterclockwise direction, and you can see that I have this one soldered up with the wires just coming straight out. I just have the heat shrink tubing just slid over this one for now, and I'll probably just shrink it up after we get a little further along. Don't forget to replace your heat sinks back on top of your ESCs like this before installing your heat shrink. We have our two front motors and ESCs mounted. I'm going to go ahead and prep the ESC for the rear by removing the heat shrink and removing these wires. But actually what we're going to do next is we're going to go ahead and jump straight to this tail assembly, and I'm going to show you how to get everything prepped for that. This is all of the pieces for our tail assembly. I'm just going to go over everything and show you how it's used before we actually start putting everything together. I do want to put a little bit of attention on this tail assembly though. This thing is nice. This is super thick aluminum right here. I really did not know that this thing was going to be this thick. This is pretty heavy duty. Obviously this is, if you want to call it, somewhat of a weak point in the TriCopter system, but this is substantial. So I don't think that you're going to have any problems with this. We have our servo. This is an all metal gear servo, and he has included a extension wire because with the flight control that we're using, there's just not quite enough length with just this to get all the way up to our mullet flight control. So we're going to be soldering on an extension. He has provided the heat shrink tubing that we're going to need to make that extension. These are our servo connections right here that we're going to need to connect up. This is the dog bone that's going to go from the servo down here to the tail assembly. This piece right here is a bracket that's going to go on top of the servo like this. This is a motor adapter that's going to mount right here on the tail assembly. The motor is going to sit on top of that. What that does is that raises the motor about 2 millimeters so that the props can clear the top of the servo without hitting it. These are the screws that we're going to use that are going to go down through here that are going to mount the servo to the tail assembly. And these are the little screws that we're going to use to connect up the dog bone assembly. So I just wanted to go over everything, what it is, how it's going to be used. We'll start putting it together. What we're going to do first before we attach this tail assembly to the 355 is we're going to attach this dog bone. It'll focus. We're going to attach this little dog bone right here to the swivel in the tail assembly. Now, the orientation of the screws and how we mount it is very important. So we're going to take one of the screws, the silver screws. We're going to put on a washer. Just slide it through the little dog bone. It's really not threaded, but it's kind of a tight fit. All right. Then we're going to install another washer on this side. And then we're going to mount it on here, right like this. We're going to put our nut right here on this side. We're doing that so that we have plenty of clearance for this to swivel. Now when you get done, you want to make sure that you haven't over tightened the nut. You want this to be able to move freely so that it doesn't bind up. That's what you should have. Next, we're going to install the servo. Now, what I'm going to do is actually install a small piece of heat shrink tubing over top of the servo, because with this anodized aluminum and the plastic, we don't want to clamp down on this servo really hard because we don't want to deform it, but it's really slick, really slick. So I'm just going to put this heat shrink on there just to kind of help secure the servo. Now, you certainly do not have to do that, but I'm just going to do it just because I feel like it makes the servo kind of stick to the tail assembly a little bit better. The next thing that we're going to do is use this bracket right here that mounts on top of the servo. We're just going to use these long screws. We're going to put a little bit of Loctite on each one of these screws. They're going to go in these two holes right here. Now I'm just going to snug these down for now, because really we don't know how everything's going to line up just yet, so I'm just going to snug them down. I'm going to tighten these evenly. That's got a pretty good grip on that servo right there, and that's just finger tight. And remember, we have Loctite on these screws, so we don't need to get too tight. The next thing we're going to do is we're going to install our servo connector arm. I'm going to show you how your screws need to be oriented to connect this up. This time the screw is going to be coming in from the other direction. So what we're going to do is we're going to take our silver screw, put on a washer, come through the dog bone in this direction, put on another washer, install the servo connection, like that, and then we're going to put on the nut. Again, we don't want this very tight. This is a nylock nut, so it's not going to come off. We don't want it crazy tight. And there we go. It's going to turn and tilt our motor up and down. Now we're ready to install this to the rear of our TriCopter. Now I have temporarily installed the servo connection onto there. Really right now we have no idea whether or not that servo is centered or even remotely close to where it needs to be. So we're not installing the motor yet or this screw. We're just leaving everything kind of loose at the moment. And we're going to install this to the rear frame. Now we definitely want to use a little bit of Loctite on these screws that hold on the tail assembly. You don't want to over tighten this, but you do want to make sure it's good and snug. There's our tail assembly once it's installed and hooked up. Okay, now we're getting somewhere, and we really haven't even done that much. What we've done is we've installed all of our arms using the 12mm bolts and the nylock nuts. We've installed the two front motors. This one turning in the clockwise direction, this one turning counterclockwise, this one will be turning in the clockwise direction. We've installed the ESCs. This ESC has two of the motor wires crossed. This ESC has our wires coming straight out of the motor into the ESCs. We've installed our tail assembly. We currently just have the servo arm stuck on there. It's not really in the correct place. I just have it stuck there for the time being. The reason we don't have the rear motor installed is because if we install that rear motor on there now, we don't have room to access the screw that goes in the middle of the servo arm. So we're going to install this motor last. Currently the servo is just installed with the screws finger tight for now. We'll tighten those up securely after we get the rear ESC installed and the servo is centered the way that it needs to be. Also, when we get to that point, we want to make sure that the linkage, the dog bone assembly, and everything is installed nice and straight and true so that nothing is at an angle that would get in a bind when our tail motor is rotating. The next thing that we're going to do is install the power distribution board. First, we want to take the nylon screws, place these up through the oval shaped holes, and we're going to put one nylon nut on each screw. This is what's going to secure the mullet flight control. I've installed the nylon hardware for our flight control board. I've left these slightly loose so that they can still be slid in case there's any alignment issues when we install our flight control. The next thing we're going to do is tin some of these connections so we can solder up our ESCs. The screws to mount our power distribution board have already been installed on our center plates when you receive your kit. You'll notice on each one of the screws there's two nuts. Those are there to allow room for our ESC signal wires to run underneath of the distribution board. You want to leave both of those two nuts in place. The power distribution board should set easily down over top of these 4 screws. If you feel like you have to force it down over the screws, then just loosen these nuts and slide them over slightly. Should fit down on there nice and smooth. We're going to go ahead and tin these connections and connect our front 2 ESCs. We're going to get to our rear ESC here in just a minute, but for now we want to go ahead and get these connected and get these wires out of the way. Now we can cut these wires to length and solder them up. Is lengthening this servo connection. Chris has provided extra servo wire for us to do that. He's also provided the heat shrink tubing. So what we're going to do, I'm just going to go right behind this connector here. I'm going to cut the wires. I'm going to strip back about 1/8 of an inch off each one of the wires. I'm going to go ahead and tin these. I'm going to cut 3 small pieces of heat shrink. Slide this down over the wires. The larger heat shrink that he's provided, I'm just going to cut that one in half. I'm going to slide it down over this wire like that. Now we can go ahead and solder them up to the corresponding colors. Want to be careful not to get it too hot, because it can actually remelt that solder. Next, I'm going to go ahead and tin the connections for our last ESC. I'm also going to tin these two corner connections for our battery wires. We're ready to mount our rear ESC. We're going to be doing the same thing. We're going to be removing the clear heat shrink tubing, removing these three motor wires, and we will be soldering the wires directly to the ESC. For now, we're just going to leave the wires loose because the soldering of the wires we're going to do last. So we're just going to temporarily mount this ESC. We're going to solder it up, but we're going to kind of leave it hanging loose at this point. I have made the power connection for the rear ESC. I have removed the clear heat shrink tubing and also removed the three motor wires. I've slid the heat shrink tubing over the ESC, and at this point, this is how I'm going to leave it, because we're going to connect our motor wires last after we've installed our motor. The reason we're installing our motor last is we need to, after we install our mullet flight control and we initialize this rear servo, then we can install our rear motor and connect our ESC.
I've soldered the wires to the XT60 connection, and it is marked, but the flat side is the positive side, the angled side is the negative side. We just need to slide the heat shrink tubing onto the wires. Shrink it up, and we're going to connect it to the power distribution board.
I have soldered the JST connector right here, which is going to connect to our mullet flight control board.
All of the soldering is complete. We have our ESCs connected, we have our JST connected for our flight control board, and we have our battery power wires with our XT60 connector.
We're ready to install our flight control board. It's important to note that though this does not have any of the headers installed yet, Chris has in fact installed all of the PIDs and all of the settings that we need for our particular DIY build. In our case, for the TriCopter 355, all of our settings are already installed onto the board. All we need to do is connect it to base flight, go to our receiver tab, set what we need for your particular receiver, do the ESC calibrations, and other than that, we're ready to go. The flight controller is mounted using one nylon nut on each corner. I'm going to go over the connections because these are different for a TriCopter than they would normally be for a quadcopter. So what you have with your TriCopter is this one here on the top is going to be S1, which is servo 1. The second one would be S2, servo 2. The third one here is M1, so that's where our motor number 1 is going to connect. The fourth one is M2, and the fifth one is M3. So we're going to connect our servo to this first one. The second one is going to be left blank, and we're going to have motor 1, motor 2, and motor 3. This is our power connection. This is going to be connected with our red wire to the top. And then of course we have our receiver header connection. Just note that it's oriented in the correct direction. The first pin being ground, the second one with this white dot, this is the positive, and then the third one is the actual signal pin. So just make sure that you get that installed the correct way. Download and run the Baseflight Configurator app. More than likely when you start this, it's going to start you off in emergency CLI mode. If it doesn't, you want to go ahead and go to CLI mode. And what we're going to do is we're going to back up all of the settings that are in the flight control as it was shipped. That way that nothing that we do, we're taking any chances on losing any of the settings. So we're just going to type in dump, D-U-M-P. Gives you all of the settings that are in the flight controller. So all we need to do is copy all of these. Right click and copy, and then paste these into a notepad document. We can then copy these back into CLI later, restore all of our settings that are programmed into the flight controller. Now that we've backed up all of our settings, we're just going to go to the Setup tab. We still do not have the battery connected. We can verify here that the model is moving. What we're going to do is we're just going to plug in the battery. We're going to initialize the rear servo, and as soon as we plug in the battery, you should hear the servo initialize. You can just take the model and just move it around, and you can hear the servo initialize. Now that the servo is centered, we can install the connector and the rear motor. Now that we have the rear servo initialized, we need to go ahead and connect this servo arm up. What we want to do is we want to make sure that we have this motor swivel centered as much as possible. Now the servo arm is splined, so we're somewhat limited in perfection. It may be slightly tilted to one way or the other. We don't want to move our servo from its initialization point. So we're going to get this centered up as best we possibly can without actually turning the servo. I've connected the linkage, and you can see where mine has got a slight tilt downward. If I went one tooth further, then I had a slight tilt the other way. So if we need to make any changes to this, we're going to make these within the flight control. We need to go ahead now and install our screw. Now that the servo is initialized and our screw is installed, we can go ahead and install our rear motor. When we install the tail motor, we want to route the wires through this opening right here. We want to run our wires through there. Now we need to install this motor adapter that's going to go between the motor and the tail assembly. We want to line up the screw holes. Now one thing that's neat about this, the way it's designed, we can actually take one of these, the longer tail assembly motor screws. We can install one of the screws just to kind of help hold our bracket in place. Since the tail assembly has openings that aren't closed, we can slide the screw through the opening like that. It'll just kind of help hold everything together while we get everything lined up. This is how I have soldered the ESC connection for the tail motor. I have one wire coming off to the right. I have the other two wires coming off on the left hand side. Remember to cross two of the wires so that we have clockwise rotation on the tail motor. We need to install our prop adapter on all three motors. We're going to be using the little screws that come in our motor package. We're going to put a little dab of Loctite on each one of these, and we're going to connect it to Baseflight and calibrate the ESCs. Now that we're done with all the hardware installation, we're going to go ahead and connect it back up to Baseflight. What we're going to do, we're going to calibrate the ESCs. And how we're going to do that, we're going to go to the CLI tab. Now we don't have any props installed, and we do not have the battery connected. We just have the TriCopter connected to Baseflight. We're going to type in set space MINCOMMAND space equals space 1800. We're going to hit enter. We're going to type in save. We're going to hit enter. Now what I'm going to do is I'm going to actually hit disconnect. Now I'm going to reconnect. Now what I'm going to do is connect the battery. We're going to go back to CLI. This time we're going to type in set space min command space equals 1050. We're going to hit enter. We're going to type in save. We're going to hit enter. You hear the beeps. We've just initialized all of the ESCs. Now you just want to go through your configuration. We want to calibrate the accelerometer. We want to make sure that the tri is on a level table, not moving. Go to your configuration. A lot of these settings are user settable. Don't spin the motors when armed, this and that. I prefer to have mine not spin. Your PIDs, these should all be set the way Chris has them set when he ships you the mullet. Your receiver, you're going to want to baseline the roll, pitch, and yaw to as close as you can get to 1500. If you don't do that, you're going to have issues arming your board. Servos, this is already done, should already be done for you, but your yaw is going to be reversed. Everything else is just your basic mullet configuration, and there's tons of YouTube videos to show you more about the mullet flight control, but this is all you really need to do to get your model up in the air. I've tidied up the ESC signal wires by tucking those under the power distribution board. I've installed the landing legs, and hindsight's 20/20, but I would install this landing leg or even maybe all of your landing legs a little sooner than I did. It was a little bit difficult getting to that screw for the landing leg after the ESC was soldered up. Now all we need to do is install the standoffs for our top plate. And install our top plate. I'm installing the two black props on the front. This would be the top right prop. This is the top left prop. And then this is the bottom prop.